Good morning, YouTubers. Sometimes I say YouTuber, I'm actually thinking more like you are a tube and I'm a tube. I kind of wish that the world line people, when they came out with special relativity and stuff, you got to learn what a world line is, and that's a fine thing, world line, but they could have called it, still, we could call it a time tunnel. That sounds kind of cool, right? And we're all in a time tunnel. It adds that kind of, I'm a world line. Sometimes we forget and we think, oh, those world lines out there. But if you get to be a time tunnel yourself, then that connects to scenario. Scenario like in the movies, or like when you're planning, like, scenario, right? So you're in a scene, you're in a time tunnel. Now there's also time tube. This ties us back to YouTube. And that's a sense in which each one of us is a test tube. We're a test tunnel, we're a test tube. We'll talk more about that another time. Okay, I didn't want to get too philosophical right off the bat. Here we've got the Facebook going and cult propaganda. Now that's kind of funny to call it a cult, but if Hexagonal Awareness project, by this time, 2020, it's the last day of November in 2020, the Hexagonal Awareness project has been tied off, but you could call it a PR project, a pro square PR project. Now this is just commercial music, and I'm actually going to turn the music off and just jump to the end of this movie. It's called Hexagons Are the Bestagons, and I would tie it into my HP4E campaign, which stands for Hexapence for Everybody, which is very obscure at this point in time because no one knows what a hexapen is. The CP4E was kind of an inspiration, right? That was Guido's computer programming for everybody. And I've tied Python there. See the cult-looking motif there? They're kind of making fun of cults in a way, you could say. But now what's the 4D analog? And you think, well, I should have said 3D just there. Or maybe I mean 3D plus time because I was just talking about YouTube's. Don't worry about it. We're talking about 4D in a different way. The Quadrays. Now, if you're in one of those elite Quaker schools, as I call them, you've probably already gotten a lot of Quadray material from tracks. All right, this was asynchronously laid down in 2020. But here we are in whatever year we're in, and Quadrays are just something you take a look at as you're learning XYZ, right? Why not? Because linear algebra is linear algebra. And vectors are vectors. It's just there's these different language games that we can play with this concept of vector. And this one absconds with our standard vocabulary and repurposes it to some degree in calling these four independent basis vectors from the center of a tetrahedron to its four corners. And we can say, but wait, one is the sum of the others. But we can say, well, that implies rotation, that you could rotate a vector. And you're saying, where? I'm not rotating anything. And I'm saying negation constitutes rotation. And then we get off on this kind of philosophical argument, but it doesn't matter because these are just namespaces. The idea that all namespaces must be reconciled in heaven to the one grand namespace of them all is not necessary, really, because that implies time to say a lot of names, and heaven is really, you think of as instantaneous. It doesn't need that kind of agreement in the slow world of people who think, period, people who think. So here I'm reminiscing with other, quote, cult members. Again, that's kind of tongue-in-cheek, kind of subgenius. Down here, Gerald and I are remembering when he came out to Seattle and we had all this fun together as early pioneers in this set of disciplines, elastic interval geometry being one of the successful ones. Thank you to Gerald and to these others, a lot of them unsung heroes. Tim Tyler, Springy, and Alan Ferguson, Spring Dance. These were early software implementations of what Gerald then went on to do as Struck. And all this continues, right? This is ongoing research into tensegrity as implemented in the software context, right? It's interesting stuff. I encourage you to check the state of the art as it is today. I'm just pointing out where it all began in terms of early pioneers. That's Alan Ferguson on the right, Carl Erickson on the left, early pioneers. So obviously we would, in quote 4D, talk about the rhombic dodecahedron at this point of volume 6. Our friend here, remember you can fill this with beans. I suggest something not too fine. In other words, the volumes are exact, but I'm thinking practically in terms of floorboards and sweeping up and stuff, that I've been using pretty large white beans to do our volume relationships, and it does suggest cooking shows, right? Kind of Julia Child's, we're doing, actually I should probably go this way, 2 of these, each of them 3, gives you 1 of these, and they all come from the tetrahedron as our unit, right? So I don't have my paperboard version, but this could be a stand-in for my paperboard. So 6 of the unit volumes go into here, and you're thinking, what unit volume, what are you talking about? That's if you're not already involved in this cult or school or whatever. So Quadray coordinates, to remind you, also build in the way I've implemented it in Python, also build in the unit volume tetrahedron, and that if I put in from any vertex radiating outward, just like we do in XYZ, we radiate outward from the origin with 3 basis vectors. Here we're just not at the origin, but at one of the corners of the tetrahedron, radiating outward with 3 of these edge vectors, but of any length. And then we multiply them together. They have fixed angular relationship in this picture. And that gives us the volume, which ends up just being those 3 lengths multiplied together. That's, 1 times 1 times 1 is 1. And you can see in my unit tests here of the tetrahedron class in Python that we're implementing Gerald de Jong's volume formula, which is echoes of the past, right? You've seen similar volume formulas, but this one gives back tetravolumes. So if I define a regular tetrahedron just as those 4 corners, those 4 vertices of the quadrays, what I get back is, first of all the edges are length 1 because we're talking in diameters, not in radii, which in that case they'd be 2, and the test volume is 1. And we can boost this up to very high precision and stop using floating point if and when we feel like it. And there have been videos on that already where I've delved into the arbitrary precision world with exactly this module and so forth. My cross-indexing I'm still working on, but maybe by now when you're hearing this you'll have a quick, in fact I can put a link right here in the YouTube, that's right. Okay. So that's what we mean by 4D in this case. Got it? It's like the quadrays define 4 directions. You could think of D for direction, but then just use the word dimension, right? Take it and use it because it's your heritage. You can use these words even if other people use them differently. And I say, this is especially going to help you understand 4G geometry of synergetics. We've got those slideshows for you to chew on, right? If you want to turn around and present them. Now here, they still don't like that this is too, doesn't have the right tone or so on, and then they're asking for money here. So the first third of the screen is not synergetics really. And then this page is, okay, donate now. This page is, written by more than me, but you can recognize this table and some of the graphics that I did. This one on the right, lower right, is actually by Stephen Hawking. Another, let's see, I've got his stuff on the first, on grunge.net. I was just remembering where he's most prominently obvious in the syllabus right from the beginning. Go to grunge.net and you'll find his clock tet video at the bottom. But then I think it's using a Flash plugin, and here in 2020, end of the year, the Adobe's push to phase out Flash is pretty strong. So this might not work for you. But Richard Hawkins, there's an S on that. It's not Hawkins, it's Hawkins. Now, he and I never met, but we did collaborate, and that's the case with a lot of you. I've worked with you in different ways. Maybe we got to meet in person, maybe not. But that's the way of the world, right? Partially overlapping scenarios, time tunnels, time tubes, test tubes. All right, that was fun, and we'll talk to you again soon.